Hello, my name is Esther Trilsch and I'm currently working as a character TD at KineFX software. In this section of the tutorial, I will show you how you can set up a procedural rig that allows you to build on top of existing animation in order to make your animation and the technical animation workflow a little bit easier. In the first parts, I will give you a little bit of an overview over the input and output structure that might be different from traditional rigs. And then I will dive right into the structure of the HDA itself, and I will give you an overview of how these inputs and outputs internally are plugged together. Let's start with having a look at the typical input and output structure of a traditional rig. Usually you have a rigger that gets a geometry delivered in the rest position, and based on that they start setting up the rig. And they start setting up a rig with controls, as you can see here, and they're usually then accessible by animators. The rest position and the rig logic itself and all the other kinds of data are usually not really accessible by anyone else but the rigger itself. The typical output that you get is then either simply just the deformed geometry or the according animated parameters that the animator sets up. And it becomes a bit tricky when you want to pipe that animation here back onto a different rig. And usually you're stuck with the only option that is very available, which means that you take these parameters here and you bake them over to, well, a copy of the rig or a rig that looks similar. And that comes with the downside that you, first of all, you use proceduralism, or that you might introduce Euler flip effects. And we can change that picture a bit in KineFX. As you can see here on our control rig, we all of a sudden provide 3 inputs and outputs, and they look very similar to the 3 inputs and outputs that you might already know from the character FBX input. So these inputs here represent the rest geometry that might also contain capture data, the rest skeleton used by the capturing as well, and an animated skeleton, which is the third option. And this comes also with the big advantage that this allows us a bit easier a split between a capture setup and a control setup. So that means in our case that what we decide on doing is to keep the whole capture setup in its own HDA, maybe even with like additional other fancy deformation options. And we're just piping that in to the control rig, and that makes the whole control rig very lightweight, which is kind of nice. It also comes with the big advantage that you can handle proxy workflows very easily because the control rig itself is topology independent. And the same goes, of course, for any kind of topology updates that you might need to deal with. You can split it into 2 sections, and it is independent from the rig that the animator deals with. Now let's have a little bit of a closer look into the effects of all these single inputs and outputs themselves. The most relevant and most important one is actually the last one, the animation input. So for your workflow, that means that you might as well start with your rig and you start with traditional keyframe animation. In this case, I provided 2 poses and I'm interpolating between them. What you can see from the output of the animation, this is what you're seeing here. This is the accordingly deforming skeleton. And we're piping that now into another instance of our rig. And what you can see now is 2 interesting things. So first of all, let me revert these values here. So what you can see here is that my controls are automatically now following along based on that input animation. And first of all the channels are zeroed out, and my changes are now being applied as pre-multiplied relative changes to that input animation. On the other side, I still have, though, the complete functionality of my IK mechanics at my disposal, which is of course really great. So I can still do IK animation and just layer that on top of my existing structures. So of course with the structure, you're not just limited to a traditional keyframed animation input. You might as well just use an FBX input, and you can layer that in, exactly the same effect. Or you might as well have the complete tool set from the KineFX world to your disposal. In this little example, I'm doing exactly the same again. I am having an FBX input. Then in the next step, I am, as you can see in this little blue dot here, I am having an extraction of the locomotion. I'm applying the locomotion to my rig, and just then I'm applying that effect into my rig itself, and I can do further tweaks on top, as you have already seen in the other examples. And you can apply a very similar effect to the second input of the rig, which represents the rest of your skeleton. And this is actually quite the neat and cool feature if you ask me. So when we start with our FBX that we have in here, we can now take also the capture input. Let's make this a preview. And now I'm going to manipulate the pivots of my skeleton. So I'm going to change the pelvis and the knee, and I'm piping that into the second input. And what we see now is that our geometry hasn't popped around, but the position of our controls and of the whole skeleton itself has adapted to that new position. So if we take that away, you can see the new positions are now completely functional and applied to the rig. So this gives you two really neat options. First of all, you can of course take your initial control skeleton that you built, and you can very easily adjust it to similar rigs. For example, if you say you have 5 different elephants with different proportions, you just change these positions here, and you're already adapted to rig to a new structure without kind of like needing to, in a scripted way, rebuilding the rig itself. And the other nice feature is you can do the same even on a shot basis. So if you realize that the pivots really don't work for a specific shot, you might as well also throw in a rig pose here to manipulate your pivots, and then you can animate on top with a rig layer with your new pivots. So that is actually even quite a handy feature for that. And last but not least, we come of course back to what I already mentioned with the split of the capture rig and the control rig. So the nice case is in our case, we did more of a procedural capture setup, which turned out to be a bit heavier. So we could in the end just export it as an FBX. So here we have no animation. It's really just a pure FBX with the according capture weights. And we can pipe that in via a character import directly into our rig. And one nice effect that we have from this is that we built into the rig is that we are of course working with a rest position for the geometry. So if I pose this rig here, my output geometry is in fact deformed, but if I pipe that in here, theoretically I would get a double transformation. But because we stored the rest is simply being applied before I do any further deformation. So the geometry pops back into its rest position, and just then we're applying the deformation from the next node, which gives us, of course, the leverage to preview always the deformed geometry, but we might as well jump back to rest at any given point. When it comes to the mechanics of the elephant, the rig setup is pretty much a straightforward quadruped rig. So we have 2 layout controls in order to position the elephant. Then we have a classic cog control to move the upper body around. And we have a very simple spline IK to move the spline and the pelvis around. And the tail and the trunk are simply a very classic FK setup. The arms and legs are a little bit more complex in comparison to the rest. So for starters, you have an IK setup, and you can see that the pole vector is automatically following along. We can control the amount of the follow with a slider. So now we turned it off and the pole vector is not following along during the motion. In addition to that, I added a feature in to help a little bit with this really ugly IK pop that you usually get. So first of all, with a toggle, you can have a small translation that helps to soften the effect if you have a non-stretchy setup. And it's definitely going to look a lot better if you have stretchy on. And then you're going to have a very nice, smooth transition between completely stretched out and the angled foot / limb. And last but not least, we can of course also blend over to a complete FK arm, and we can animate that as well. When we dive into our HDA, we see that the HDA is pretty much split into 3 bigger sections. The first and smallest section is down here, and this handles the deformation of the geometry. The midsection up here is handling the setup of a rest skeleton, and on the right hand side, this biggest block here handles the setup of a control skeleton where we expose the parameters to the rigger, and this control skeleton is then used again to control, of course, the rest skeleton that we previously created. I'm not going to go into detail of the first section that I already mentioned because it's pretty much just the extraction of a rest position and the application of a bone deform. So let's rather have a look at the midsection, which handles the setup of the rest skeleton. So the starting point that we have here is the setup of a skeleton, of a classic skeleton node. So if we look a little bit closer here, we can see that each joint here gets an according name, and we simply placed it at the atomical correct position that we need for our rig to function. In addition to that, I have two small procedural setups to help me with the trail and the trunk. So you can see these ones here and here. And if you look at the setup, I'm just starting with a simple curve with the curve tool to define the position of my joint chain that I want to create. And then the next step, I'm resampling that curve. So you can see that here on these positions. And the amount of segments that I'm setting up here pretty much represents now the amount of joints that I want to have on my curve. And in order to turn these points on the curve into joints, I'm using the rig doctor. And here I have the option to set up a proper name with the prefix. And I'm also initializing some transform values based on the orientation to its children via that node. And just to be safe, I'm still handling orientations with the trunk orientation node in addition. Now I have these three elements combined, but what you can see is that, of course, I'm still missing the parent relationship between the trunk, my procedural elements, and the skeleton. That is being done with a parent joint nodes. So I'm simply parenting them under here. And as a next step, you can see I just built one side of the skeleton. I'm handling with the skeleton mirror a classic mirror of the skeleton to the right body side. The next step that currently needs to be handled with a wrangle is actually quite an important one. What I'm doing here is I'm setting up the scale inheritance for my rig. Per default, the scale inheritance is set to 0, and that means that each joint inherits the scaling from its parent joint, in addition to, of course, the according transform offset. And that is usually quite handy for FK setups, and is in a lot of scenarios quite useful, but you should be aware that it can lead to certain problems when you have non-linear stretches. And this can, of course, occur as soon as you, for example, work with IK stretches. For example, in a classic 3-joint IK setup, you will usually use non-linear scales for handling stretch effects, or also on IK splines. And whenever you have these non-linear scales, that is not something that you want to have. For example, if you have an arm, you don't want the hand to non-linearly stretch after that as well. So you rather should set up your scale inheritance accordingly to 1, and that means that the offset of the scaling is being properly transferred over, but you're not inheriting the non-linear scaling itself. And one thing that you should always be aware is if you have these non-linear scaling that you're inheriting, you might as well create shearing effects with that. And that can create serious problems as soon as you, for example, start to export your rig as an FBX. So be aware of that and take care of setting up the scale inheritance properly. The next part that we're going to have a look at is the very interesting part, because this one allows us to transfer different rest positions over to your rig. And for that, I added pretty much 2 options into the rig. And if we go up a step and have a look at the parameters here, you can see that I have a directory to an FBX file. And the reason for that is simply to save the animator an additional node that they always need to create just in order to load in the default rest position and default rest geometry. And this FBX is being imported via a character FBX node, as you can see here. And one interesting thing that I'm going to point out is that I'm not using the middle input, which is the capture rest, and pipe that in here to my rest, but I'm actually using the animation output. And first of all, of course, I know that the rest FBX file that I stored out has no animation. Another reason why I'm doing this is that the second output actually represents the capture rest pose. And the capture rest pose might as well be a sparse set of your joints that you have for your complete animation. If we have a look at the elephant, for example, we have here this origin joint that we are using, but this origin joint is not a joint that we use for the capturing at all. So if I would pipe in the second input, I would miss this whole joint that I actually want to maybe have in order to manipulate my rest position. So the third input is in this case a safe option to handle. One thing that you need to be aware of though is that you should go to the time settings and delete the time and delete the default expression that you have on the time parameter and just set it to, well, the according frame that you want to pick for your rest position. Otherwise, if you don't do that, that leads to the fact that this import is time dependent. That means it evaluates every frame you move along, and this will make your rig very slow. So this is really important to kill that if you want to use the animation input. In order to blend that animation now into our skeleton that we just created, we use a skeleton blend node. This node allows you to either blend the local or the world transform of your skeleton based on the name or other matching attributes. And it's going to be used a lot for transferring animation from one rig to the other. And as a tip, I would usually go by name and not just by joint number, because FBX imports might have very different joint numbers than the skeleton that you're working with. But this node is pretty much your best friend for different scenarios of blending positions and animations. If we are going now down, you see a very similar pattern. Now I'm taking the second input that I have. So if we have it here, it's that gray input. I'm using again a skeleton blend. I'm matching by name. I'm transferring all my components. I'm using world space just to be sure. And I'm transferring that animation over if I have that second input as a provided option. And just to be on the safe side, I'm also applying a rest pose that might be handled in further steps further on. The cache if here is really just a safety measurement in case that I have a time-dependent rest input, just to make sure that I don't create any time dependency on my rest skeleton. Now we're coming to the next important section up here, which is the setup of the control unit and the control logic. And before we do so, let's have just a quick look and check where the outputs of our rest skeleton are actually going. So first of all, of course, the rest skeleton is being used for the deformation, for the bone deformation itself. We are also providing it as our second output, as the rest skeleton output. And the interesting ones are these two here that go directly into our control setup. And this is actually the very amazing and flexible part of the setup, is that any kind of changes, be it transformation or orientation or whatever, directly flows into our control rig, and the rig dynamically updates based on that. And this is really the beauty of proceduralism when it comes to rigging. So when we want to create now our control rig based on this core skeleton, we might want to add some joints. And in this case, I duplicated a few joints for the feet, because I need that for an inverse IK setup. And I also added a few joints. So I added a cog control, and I added some pivots for the heels for this IK inverse IK foot setup that I already mentioned. And in this case, I used a simple skeleton node, but you might as well want to use additional options to promote these transformation values up to your rig so that you can dynamically manipulate them. But in our case, it was completely sufficient to just like hard set them into the rig with the skeleton node. Then we simply mirror it over and we merge it all into the existing skeleton that we already have. The next step here is actually quite an important one, because what we are doing is we are parenting the new cog control and the heels under existing joints. And this hierarchy is quite important if you want to transfer animation over to your controls, because if I now transfer to this FK skeleton, let's say an input animation, the cog control is parented under the spine mid, so it will accordingly move along with the spine mid and it will get that transformation. And I will show you, of course, in a second later how this transformation effect for the animation works, but just keep that in mind as a starting point. The next initial thing that I added at this point was just a neat little trick for coloring. So I just added a color for left, mid, and right for the body sides to make later control coloring a bit easier. And of course, I'm also adding some groups in order to make the handling for the arms and the legs a little bit easier at that point. Now that we have all the control points that we need, the next thing is that we need to do is change the transformation and the actual hierarchy to match more to our control rig needs. So to start with, the first thing that I'm doing is I'm nuking the complete hierarchy. So you see all joints are now parented to world, and you can do this simply by using a wildcard and setting everything to nothing, which means you set the joint parenting to world. And then I'm creating another instance of the same node. And here in the viewer state, I just reconstructed the hierarchy to my personal liking. And you can see here, you can still find these FK structures, for example, for the tail and for the trunk. And what you can see on the legs, though, is if you have a closer look here, this one here looks a lot more like an IK hierarchy. So we don't have the classic FK hierarchy anymore. And what I reconstructed here is an inverse foot setup, just from the hierarchy. So now that our original joints for the knees and for the elbows have are to be turned into pole vectors, there's one thing that we notice, and this is that the orientation that we're having is not really helpful at this point. So what we want to do in the next step is we change the orientation to a world orientation, because this is something that animators very often prefer. And we simply do so by setting the world transfer matrix that all these joints initially always have to an ident, which pretty much puts them into world position. As a next step, we also want to give these pole vectors a small offset, because usually it's not very handy for selecting if they're sitting directly on the joint itself. And we have a little slider for that. You can see that here. And all it's doing is multiplying a translation value to the transform matrix. And the good thing about that is that we are keeping the orientations of our joints, the planar orientation. And that is very important for the IK setup, because you don't want to change the initial orientation with your IK setup just because you gave the controller a little offset. So now that we have these nice little changes, we do want to store these offsets that we just created in a very general procedural matter in an attribute which stores the local transformation. We're just calling it offset. And this is something that we will then need when we want to transfer our animation over. But before we come to that point, there's one thing that we're still missing, and that is the creation of control elements, because right now it's a bit hard to select, well, any joint here. And that's what we're going to do with the attached joint geonode. In order to feed anything into it, we first create ourselves a little shape library. So we have these local shapes that we're building, like a circle, a box, and a few other elements, and we are all merging them into a packed merge node. Here they're also getting automatically nice names that we want to have. And this shape library is something that we pipe into the second input of our attached joint geonode. In the viewport, we can then create these selection groups that you can see here. And with the middle mouse scroll, you can then change the according assigned shape for that group in a fairly intuitive and fast manner. And you can also give each of these controls a different tweak and transform offset in order to shape them to your personal liking. And one thing that I did here, because I was a bit lazy and I didn't want to set up per shape the color, was that I used this control shape, this color attribute that I previously created, I'm just using this here as a color attribute. And you can see here, plonk, the colors are getting directly transferred over to our controls, and it's being automatically handled by that. So much more convenient than setting it up manually. Now I'm going over to the animation section here, and now the really interesting part starts, where we're actually transferring over the input animation from our third input. And this is actually a process that takes several steps, and I'm going to go over them now a bit more in detail. So the first thing that we are doing is, see, we are taking back the initial control skeleton that is still in the FK hierarchy and has no offsets, and we're taking that one and we're transferring via a skeleton blend the local transform over to our skeleton. And yay, it moves. You can see that. And you can also see that the extra joints that the extra controls that we created, here's the cog and the heel, they are also now nicely moving along because they're parented to the according elements. And this shows now the importance of that. So now, of course, we want to transfer that with the additional controls over to our new reparented skeleton that we have here. So for that, we take another skeleton blend node, but with different configurations. So the first and the most important difference that you see here is we're transferring that motion now over in world space. And that means that it's not taking the local transform, because I mean, that will not really apply anymore because we changed the hierarchy. That means the local transformation values will be totally different. But we know that the skeletons will have exactly the same proportions, so taking world transform is a completely legit option here. And if we move along in the timeline, you can see, yay, our controls are also moving along. But you can see one thing. The feet are still having now all of a sudden this really weird orientation. That's not really what we wanted. And, you know, we created this really nice offset for the pole vectors, and all of a sudden they're clunked back exactly through the joint position. And that's, of course, not really what we want for our transfer. So now we're coming back to the part where we are transferring over this offset value that we created here. This matrix is now being pre-multiplied to our controls. So you can see they're now getting back this position. So we're just applying that value before we're applying the animation. And so the delta is being reapplied, and all of a sudden our controls are back to the nice position that we want to have. So you can see this with a rig visualizer. Here, you can now see the nice offset effect that we are now getting. So there's one little thing that I added as an additional step, is that, you can see this up here, is I want the pole vectors to be always oriented to world space. This is of course a personal choice. So instead of always being reoriented based on the input, I wanted them to be completely in world space. And you can see again, I'm applying an ident value to the transform, and that pretty much kills any input that I had before and orients them just completely to world. And this is of course a style question. You might as well want to have a toggle for that or not have that. This pretty much depends on your animator's needs. And with the rig pose node, we're coming now to the section where we're giving the animator back the control over the controls. And we're doing that by promoting various channels of the different segments of the controls up to our rig. And if you look at it, you could, of course, as a very easy option, just promote the transform multiple up to your rig. But there's one thing that you need to keep in mind. If we go up here and we have a look at the sheer amount of parameters that we have here, this is already quite a lot for an animator, and it needs to be managed. And if you just promote the multipalm with all its options up, you give the animator quite a lot of data that they need to manage. And it's usually better to talk to them precisely about what they want to have instead of just giving them the option for everything. So it keeps the whole rig and everything a lot cleaner if you do so. And you can also hide certain options where you definitely don't want your animator to ever fiddle around with, like maybe the transform order in certain cases. So what you can also see though that I'm doing in the node is that I'm setting up the rotation order here per joint. And as you can see, just the parameters themselves are promoted, not the rotation order itself. And one other thing might be also interesting. If we go now to the node, one thing that you will instantly see is my joint lines have disappeared and these blobs, the joint visualizers, have also disappeared. So how am I doing this? I am simply going over to the settings of my rig pose node. And here I have the option to configure the rig visualizers. I can control if I want to see the joints themselves or the polylines. And I can simply hide them. And I can do this for various groups. I can also, of course, put expressions on it in order to automatically handle the visibility of certain elements. For example, if you do an IK-FK switch, that might come in very handy to have an expression in this one here. The next step that we're doing is to add the point constraint that I mentioned previously in order to choose if the pole vector should follow the hand animation or not. So if we go up a step and we simply take the elephant's hand and move it along here, you can see it a bit clearer. So now we added an animation change. So first of all, our control was positioned here, and now we created this offset here. And what we want to do in the end, we just want to apply that offset that we made to the pole vector. So in order to do that, we are creating a little VOP setup, and this is being done here. The setup itself looks maybe a bit more scary than what it actually is, but what we're doing is we're simply taking the rest position of the driver, which is the position before we hit the rig pose node, and we're just creating the delta by simple subtraction. And all we're doing that is just like transferring that over as an offset value to our pole vector. And all the stuff that you are seeing here is nothing else but a management for saying if you want to blend it and if you want to toggle it off and all these things. So it might look a bit more scary than what it actually is. In like vector mathematical terms, it's actually very simple. And because our pole vectors in the animation are dependent on that, we need another rig pose node. And up here, we're actually setting up the control parameters for our pole vectors. And that brings me up to one more important point, which is I would not recommend to clutter the whole rig with rig pose nodes. Rather use them wisely and use just as many as you actually really need, because the more you add, the more nodes you have where you need to manage the visibility and the promoting of the parameters, and it easily gets messy. So use them wisely and just use them really if you have these upstream dependencies. Then of course you will add more than just one. So now we have this really nice IK setup for our feet. But what I also showed was that we also have an FK setup. And you can see this here in these blue nodes. One thing that I didn't mention before is that we also set up a few control shapes for them. And since it's just an FK, we can just do a direct FK transfer from our original animation. And we might as well also need to transfer the position for any kind of like shoulder twists or offsets from our rig over with a skeleton blend. That's what we are doing here. And then in a similar fashion as before, we're also promoting the parameters up. And here you see I'm just promoting the rotation up. And I'm managing the visibility, as I already mentioned, with an expression. So whenever this one here is, of course, off, then the visibility on my IK setup is on. So it's a counter switch. And this is how I can manage these kinds of effects. And with this, we're now through with all the steps in order to have promoted control abilities for the animators to set up IK and FK controls. The next part that we're going to examine now is the transfer of the control animation back to our deformation rig, aka the rig that we created in the very beginning. So the first part is a direct transfer of the world transformation over to our rig. And we can do that very much straightforward for all the FK parts, for the tail and for the trunk and for the head. There we just know that the joints should be exactly where the controls are. The yellow section that follows beneath handles the IK setup, and the blue one handles the FK setup for the limbs. And when we come to the IK setup for the legs, I use the IK chains node, and that node is pretty straightforward. So you define for your 3-joint IK, you define your root joint, your mid joint, and your tip joint, simply by giving the according name. And because we derived our rig directly from the control skeleton, we know that the names match exactly, so we can just use the match by name option. And that pretty much creates the solve for the IK for us directly. There's one small thing that I added that I also showed already in the parameters, and that is this handling of an IK that gives you less of an IK pop. And if we go to the rig visualizer here, and I just added this rig pose here for demonstration purposes. If I now take this foot, what you can see here, what I'm doing is I'm manipulating the rest position that goes into my IK before it's even being solved. So I'm applying a stretch scale before the IK even is doing anything. And that is being done with a VOP setup that pretty much merges two circular functions. I'm not going to go into the details of how I'm mathematically set this up. This setup will be also part of the content library, so you can have a detailed look into that yourself, but it's really just putting these mathematical snippets together. But what I wanted to show is exactly that neat effect that you can fiddle around with the rest position that you pipe into the IK setup, and you can get some really neat little trick results out of this. And this here is the option for stretch, which just applies this non-linear stretch effect to the rest position. But if I go up to the rig and I turn stretchy off and we dive back in, you should be able to see, yeah, you can see this here. This is a small translation applied to the root in order to imitate the behavior. It's definitely not as great as the stretch version. It will never be. But in certain scenarios where you cannot really work with non-linear scale values, it might be still better than nothing in order to give you some sort of the effect. You can also tolerate the tolerance in order to tweak it a bit more. But still, you have an option for both setups. I can show you a bit more in detail now the IK spline setup. So if we dive into the VOP setup, you can see I'm pretty much just giving my joints from my deformation rig. I'm piping them directly into the node as my target points. And I have my points from my control rig. I just defined the group here. And I'm piping them in as my control rig. And the solve curve handles the IK spline setup pretty neatly for us. And all we need to do is in the end, we just use the points and we update their transform matrices. And the effect that you're getting from this, if you're going here, is that if I'm now moving the spine mid control, you can see that I get a much softer solve than the pure modification that I get when I just translate the control directly. And this is, of course, very nice and neat. In the case of the example that we have, it just happened to be that we have the same number of joints for our control rig that we have in controls. This is really just happened to be that way. You might as well have 10 joints for your control rig. It would work equally well. So now, of course, we have this very last section here, which is the FK solve. And the FK solve is, again, nothing but a skeleton blend. And we're doing a local transfer in this case. This is important. And we are controlling this bias here is what we promoted up. And this is being controlled by the FK blend. And this is just basically making an override to everything that we did before and just blends back to the FK. And we're splitting this up into the 4 sections so that we can control each of these elements independently. And we're doing so by 4 nodes. And the according animation that we now created is the REST skeleton with the transferred animation. This is also what we are providing as an output. And when we're going here, this controls our animated elephant. And now we pretty much covered all the points that enables us to set up this animated elephant and to give you the option to have a flexible setup with flexible rest position and animations. And for further animations, how you can use that in combination with dynamics and in the combination for animation and what that in detail means, you can watch the other parts of the tutorials being done by my colleagues Michna and Warren. Thanks for watching and bye.